Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at killers of crankshaft. What are some of the killer mistakes that can ruin your crankshaft and shorten the lifespan of your crankshaft? This is a 4-cylinder crankshaft. You see here there is one main journal. Here there is a crankshaft connecting rod connection. Here we have a crank pin where cylinder number 4 is connected. This is cylinder number 3. Here we have a main journal again for supporting the crankshaft, and cylinder number 2 and cylinder number 1 are to follow. Now, when working or when rebuilding an engine crankshaft, some mistakes might happen, and that mistake might result in failure of the crankshaft. So certain mistakes can lead to catastrophic crankshaft failures. Well, the crankshaft is roughly regarded as the backbone of the entire engine. If the crankshaft is not working properly, then there is no engine. Literally, there is no engine, because the crankshaft is responsible for receiving the power that is produced inside every cylinder. It is responsible for converting this reciprocating motion of the piston to rotary motion and then supplying it to the flywheel, and the flywheel will then supply it to the transmission. Or if it is an automatic transmission, the crankshaft will supply power to the flexi plate. The flexi plate will give power to the torque converter and then goes to the automatic transmission gearbox. So the crankshaft is therefore a very crucial and critical component. So what are some of the things that can result in early crankshaft failure? Well, number 1, improper torque specification on the crankshaft, on the main cap. Here the crankshaft is supported by these main cap bearings. Here we have one bearing, here you have another, and at the front there is another. Now, these bolts that are fixing the crankshaft cap to the cylinder block, they have a specific torque, and that torque has to be maintained. If that torque is not kept, that can ruin the crankshaft. For example, over torquing, it could result in damage to the crankshaft. Under torquing, it can result in damage as well. So it can cause bearing failure, its span bearing, or even cracked crankshaft can result as a result of improper torquing. So always use a torque wrench when fixing crankshaft main journal, bearings and bearing shells and all those cap bolts. Always use a torque wrench and follow the manufacturer's recommended torque specification when fixing this. Include torquing sequence also. It has to be sequentially tightened, and if there is an angle torque procedure, it has to be followed as well. So the number 1 reason of a early crankshaft failure is improper torque specification on the main cap bolt. What else? The second problem is incorrect bearing clearance. There has to be a bearing clearance between the crank pin, between the main journal and the bearing. Similarly, there has to be bearing clearance between the connecting rod cap and the crank pin. That has to be kept. Now, not checking bearing clearance with a plastic gauge or micrometer can result in early failure of the crankshaft. If it is too tight, for example, if the bearing clearance is very narrow, if it is too tight, that will result in oil starvation. Oil has to be made available in between. Oil will be there to lubricate. There is an oil passage inside the main journal that has to be supplied with a proper clearance. Look here, for example, there is an oil passage. Oil will come to the main journal through this gallery, through this passage, and it has to circulate. If the clearance is very tight, if that oil is not circulating enough, that can result in accelerated wear. If it is too loose, however, that will result in knocking. The crankshaft, it should not be playing in here. It should not be playing in this clearance. If the clearance is wide, it will be playing. There will be excessive knocking and span bearing will be there. So proper clearance has to be maintained. 3, poor crankshaft balancing. Another problem with the crankshaft is it has to be balanced. It has to be statically balanced and it has to be dynamically balanced. Throughout the entire length, the crankshaft has to be balanced. The crankshaft has to be perfectly balanced so that it can rotate smoothly. Crankshaft is rotating at extremely high speed. For example, when engine is running at 5,000, 6,000 RPM, this is revolving like 5,000, 6,000 per minute. So it has to be well balanced. Balancing has to be properly done. Reusing an unbalanced crankshaft or not balancing it after modification can result in early failure of the crankshaft. What will be the problem? If the crankshaft is not balanced statically and dynamically, that will result in excessive vibration, premature bearing wear, and potential engine failure. So crankshaft, as it is rotating at high speed, it has to be balanced. Local balancing, for example, when piston connecting rod is moving up, this counterweight is moving down. Similarly, for this cylinder number 3, when piston and connecting rod is moving down, this counterweight is moving in opposite direction. That will cause the balance, and the entire size of the crankshaft, it has to be balanced. If this balancing is not done, that will result in excessive vibration. So always have the crankshaft balanced, especially if there are maintenance procedures done on the crankshaft. It has to be balanced. And whenever you are replacing connecting rod and crankshaft, connecting rod and piston, it has to be weighed and it has to be balanced to the previous weight. Otherwise, that will result in unbalanced crankshaft rotation. The fourth thing that can ruin the crankshaft and shorten its service life is wrong thrust bearing. The crankshaft end play from front to rear end play is prevented and controlled by the thrust bearing. Installing thrust bearings backward or misaligning them can cause excessive crankshaft end play, leading to crankshaft failure. Excessive crankshaft end play can lead to erratic timing, it can lead to oil leak, and it will finally lead to catastrophic engine failure. So the thrust bearing will prevent the crankshaft from excessively moving to the front and to the right, so that always ensure the thrust bearings are properly seated, and always ensure that the end play is within specification. Number 5, dirty or improperly lubricated journals. If there are some dirt, if there is something preventing proper oil lubrication, that will also result in crankshaft failure. Installing bearings on dirty journals without proper assembly loop can cause failure, and this can result in scoring. It can result in overheating and bearing failure. And as you have seen previously, there is an oil drilling on the crankshaft journal that will bring oil. It has to be open and clean. This passage, once the engine is serviced, make sure that all these passages are open and clean. You have to blow them with a compressed air and clean them. Make sure that there is no dirt accumulated in between. Otherwise, if this is not thoroughly cleaned and if sufficient oil is not lubricating the crankshaft, that can result in early crankshaft failure. So clean the journals thoroughly and use high quality assembly loop whenever you are undergoing assembly. Ignoring crankshaft straightness is another problem. Excessive vibration will result if the crankshaft is not straight. So crankshaft straightness can be measured by placing the crankshaft on a V-block at extreme ends and then measuring it in the middle journal by using a dial indicator. There is a problem with the crankshaft bending. If it is bent beyond the specification, when it is installed, it will result in vibration. That extreme vibration will result in crankshaft failure. It can even result in crankshaft breakage. So don't ignore crankshaft straightness. Always make sure that the crankshaft is straight. And if you have disassembled the crankshaft and whenever you are storing, place it in a vertical position so that it will not be susceptible to bending. Number 7, incorrect flywheel or flexi plate installation. At the end of the crankshaft, either a flywheel is installed. For example, for this particular engine, we have a flywheel installed at the flange, and on some of the automatic transmission vehicles, flexi plate will be attached. So uneven torquing of the flywheel bolts or uneven torquing of the flexi plate attachment bolts, and not seating the flywheel properly or not seating the attached flexi plate properly can result in vibration. If the crankshaft is not properly torqued, if the bolt is not properly assembled, it might result in broken bolts or even a snapped crankshaft flange. So always make sure that the flywheel or the flexi plate is installed correctly, and always make sure that the bolts are torqued to the specification. Use the correct bolt and torque them evenly with a star pattern. Whenever you are installing flywheel on your crankshaft or whenever you are installing flexi plate on the crankshaft, use a star pattern when torquing the flywheel bolts. Also make sure that you are maintaining the torque specification. Using a star pattern will ensure proper alignment of the flywheel and the flexi plate. And the other problems that can lead to early crankshaft failure is skipping oil passage cleaning. As we have said earlier, there are oil passages, oil drillings are there. For example, oil from the engine block will be fed through this passage, and then it will be distributed to the different crank pins. It will travel through here and it will come to the crank pin. Similarly, it will go to the connecting rod crank pin assembly as well. Now, after engine has been repaired, this passage, it has to be cleaned. Not cleaning oil galleries after machining or after storage can result in debris. If debris clogs the oil passage, that will result in oil starvation and premature crankshaft failure. Always make sure that you are cleaning this passage with the compressed air, and always you can use refilled brushes in order to clean them. So make sure that they are blown, make sure that they are clean, and make sure that there is proper oil flow. And finally, worn crankshaft seal installation. And finally, wrong crankshaft seal installation is another cause of premature crankshaft failure. You know, there are crankshaft seals at either end on the drive side, and at the front there are crankshaft seals preventing oil leakage. Damaging seals during installation or not lubricating them can be a problem. This mistake will result in oil leakage. If there is oil leakage, that will lead to low oil pressure and engine damage. So always make sure that the dynamic seals are well pressed. Oil leakage can result in oil starvation at the crankshaft and other engine components. So always use sealer installation tool and lightly lubricate the lip of the seal in order to make perfect fit. So always double check for tolerances and clearances on crankshaft. Make sure that all the bolts are properly torqued, and make sure that you are following factory procedures and assembly repair manuals in order to make sure that the specifications are all kept. Single mistake can really destroy the entire crankshaft, and once the crankshaft is damaged, the entire engine will be out of use. So that is why it is very crucial and very critical to follow these maintenance tips whenever you are repairing a crankshaft and whenever you are working with a crankshaft. By doing so, you can elongate the service life of your crankshaft. As we have said earlier, the crankshaft is the backbone of the engine. Always make sure that it is well maintained, well balanced, and well lubricated. Well, dear viewers, that is all we have for you regarding some of the things that can kill your crankshaft early. If you find this video helpful and if you like what has been presented, please smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.